Hey there, Sam. Let's talk about the var keyword and why we shouldn't use it at all. Suppose we have a variable called a, which is defined using a let keyword, and we have another variable, b, defined using the var keyword, and lastly, a const variable, c. And here's a situation. Let's create an if statement, and I'll pass in true in a round bracket, so the if statement will run. And inside the if statement, we'll redeclare variable abc and reassign the values to the number 2. Now, if I console out the variables a, b, and c, after the if statement, what do you think will happen? What would we see in the console? Pause the video and think for a second. The answer might surprise you. So, let's take a look at what will happen. For a, we get the string a, which is the initial value. For b, we get 2. And for c, we get the initial value as well. So what the hell is going on here? Let's break it down bits by bits. Before we move on, I want to introduce you the concept of scope. Now in JavaScript, every time you see the curly braces, it means we're entering a new scope. It could be an if statement, a for loop, a function, or even just a pair of curly braces on their own. Just a side note, even though the curly braces of an object is the same as the curly braces of a scope, they are not the same concept. So don't get confused by them. You can think of a scope as a room that separates variables. Whatever variables that we define in a scope stays inside the scope. And once we exit the scope, the variables will just be dumped into the garbage bin. And this explains why are we getting the original value for a and c. So the variable a and c that we define inside the if statement is different to the variable that we define above. And once we exit the scope, they will be gone. And the variable a and c down here is referring to the a and c that we define up there. Now, you might be wondering why b has changed. The reason is var variable sucks, and they do not follow this rule. In other words, var is not scope safe. I'll show you why this could cause an issue in just a minute. For now, let's take a look on how JavaScript finds a value for a variable. Suppose we console out the variable a. When JavaScript runs this line, it will first look out for the declaration of variable a in the current scope. It found the declaration in this case, but we're trying to grab the variable before we declare it. That's why we're getting an error. If JavaScript couldn't find any declaration in the current scope, it will try to look up in the parent scope. I'll show you what I mean. If I comment out the variable a in the current scope, the console log here will be referring to the a above, which is from the parent scope. And if JavaScript couldn't find anything in the parent scope, it will go further up into the grandparent scope and great-grandparent scope until it couldn't go further up anymore. In other words, it won't stop until it hits the global scope, which is everything underneath the script tags. So now let's go back to our previous question. How could var cause an issue if it is not scope safe? The short answer is it could unexpectedly override the value of an existing variable and causes bugs in our program. Let's take a look at an example. Suppose we have a variable called index, and this index variable holds some very important information that's needed later in our code. And now let's say we've got a for loop, which coincidentally using the variable index as its counter. And now let's see what will happen to the index variable after the for loop. Oh shoot, we get 4, which means our important information has been overwritten. Can you see how this could lead us to bugs in our code? Our program now thinks that the number 4 is the important information that we previously defined, and carry on to use this number to perform the corresponding important operations. And this is very, very bad. So how can we fix this? The answer is very simple. Do not ever use the var keyword. If we change var to let, our problem is instantly gone. The reason is, by using let, the variable index in the for loop lives inside the for loop's scope. And it is not the same as the index that we define outside. So as soon as we leave the for loop, the index variable in there is gone forever. And the index variable outside remains as itself. And now for the next part, let's take a look at another weird behavior of the var variable. Let's create a scope, and inside this scope, we'll have 3 variables, defined using the var, let, and const keyword. And we'll console log them outside the scope. And as expected, our let and const variable give us an error because we're outside the scope. But the var variable is printed out just fine. Why is that? Again, this is another weird thing about var. This is something called hoisting. So hoisting means raised up. When we declare a var variable, it doesn't care about what scope we are in. It will always get hoisted up to the global scope. So even though we declare this variable inside the scope, JavaScript will hoist the declaration up to the global scope and assign the value to the variable inside the scope. So to JavaScript, this section actually looks something like this. So again, var variable sucks, and they are hoisted up whenever we declare them. Moving on, let's look at another example. We'll create 3 new variables. Again, a let variable, var variable, and a const variable. Now if we try to access the let and const variable, JavaScript will throw us an error. And that's normal, because how can we access something if that's not declared yet, right? Well, to var, rules doesn't exist. JavaScript will not throw us an error if we try to access the variable before it is declared. Why? Because of hoisting. When we declare a var variable, JavaScript will hoist this variable upwards to the very top. So similar to before, to JavaScript, this block looks something like this. And that's why we get undefined for this variable. So the conclusion here is that we cannot access a let or const variable before declaration. But for var variable, JavaScript will not throw us an error, but will get undefined for the value. The last weird thing about var is that var variable are added to the Windows object by default. So if I try to console out windows.avar, we get a value. But if we try to console out the let variable, we get undefined. So these are the differences between var and let and const. If you can get one message out of this video, I hope that it will be, do not ever use var. Otherwise, people will start to hate you. Alright, key takeaway, var sucks, and var is not scope safe. Var variables are hoisted up. That means they are raised to the top of the global scope. We can't access a let or const variable before declaration. And finally, var variables are added to the window object by default. That's it for now, and I'll see you again shortly. Hey there, Sam. There's a special variable called this in JavaScript. What does it do? Well, it represents the context of your code. I'll show you what I mean. For example, let's say I have a car object here, and the car has a model and a brand property, and also a drive function. And let's console out the this keyword inside the drive function. And we'll run car.drive. And surprise, surprise, we see the car object. So why is that? And again, the this keyword represents the context. So in here, we're calling the drive function on car. The context here is the car object, and therefore we get the car object from the this keyword. Now what would happen if I set a new variable equal to the drive property of the car object, and then we call it right away? What do you think will happen here? Would there be any changes? Only one way to find out. And we get the Windows object. What the hell is going on here? Let's break it down. So again, the this keyword represents the context. Here we made a copy of the drive function into a boom variable. And then when we call this function, we're no longer calling it from the car object. So the context here is no longer the car object. The context will be by default the global object, which will be the Windows object. So that's the reason why we see Windows in the console log. And one more question. What do you think will happen if I just console out this out of nowhere? It is the Windows object. Why? Because, as we talked about just now, the this keyword defaults to the global object, which is the Windows object in the browser. Okay, now, why do we need to care about the this keyword? The reason is the this keyword could be handy when we want to update the properties of an object inside an object's function. For example, suppose we are creating a game, and this game has a toad character. The toad has an X and Y position, and also some functions to control the movement. So move left will be a function that takes in a unit input, which will tell the toad to move to the left on how many units. So here we want to update the X position. We will just decrement the X pose property by the unit supplied. So what we can do here is to type in this.xPosition minus equal to, which means decrement, and our unit parameter. So this line will decrease the X position by the unit supplied. In other words, move the X position to the left. And similarly for the other direction, we can do the same using the same format. And we'll also create a getPosition function, which will just print out our X position and Y position. And now, if we tell our toad to move right by 50 units, and we call the getPosition function directly after it, we'll get 50 and 0, because now the X position property has been increased by 50 units by our moveRight function. And all we're doing here is to use the this keyword to update our object properties. Let's take a look at another example before we end the lesson. Now suppose I have an inner function inside my getPosition function here. And inside the inner function, I'll just console out the this keyword. What do you think will happen if I try to run the inner function? Would the this inside the inner function be the window object or the toad? Let's find it out. We'll run the inner function. And we get the window. Why? Because we're calling inner on its own without any predefined context. So by default, JavaScript will set the context to the global object, which is the window object. So a quick way to find out what the this keyword is to check what is calling a function. If we're calling a function from an object, then the this keyword would represent the object itself. However, if we're calling a function on its own, just like the inner function here, the this keyword would represent the window object. And that's a quick intro to the this keyword in JavaScript. Key takeaway for this lesson: the this keyword represents the calling context. By default, the this keyword resolved to the global object, which is the Windows object in the browser. The this keyword is very useful to access information in the current context. For example, to get or update properties inside an object. That's it for now, and I'll see you again shortly. Hey there, Sam. So we know that there are two types of function in JavaScript. First of all, the normal function, and also the arrow function. Let's take a deep look on how arrow function is different to the normal function. Difference number one. We can omit the return statement and the curly braces in an arrow function when the function logic is a one-liner. For example, let's say we have a function called multiply, and the multiply function accepts two arguments, x and y, and the result of this function is simply x multiplied by y. But instead of writing out the curly braces and also the return statement, we can shorten it to x multiplied by y directly after the arrow. It looks much cleaner, right? If we take advantage of this feature, it can really cut down a lot of lines in our code. Okay, difference number two. When the function only has one argument, the round bracket is optional. For example, let's create a function that will add 2 to any number that I pass to it. So in this function, num is the only argument, so I don't need to surround it with a pair of round brackets, and this function will return num plus 2. And again, the function logic is a one-liner, that's why we don't need the curly braces in the return statement. And finally, difference number 3. The this keyword in an arrow function is automatically bound to the parent's context. I'll show you what I mean. Suppose we have a car object, and we have a property, color, and a drive function, which has an inner function. We'll declare this inner function using the traditional function syntax. And inside this inner function, we'll console out the this keyword, and we'll call the inner function right away. Now, what do you think will happen if I call the drive function? What would the this keyword be? Only one way to find out. So, we see the Windows object in the console. But why is that? The reason is we're not calling the inner function on any context. So JavaScript by default will resolve the this keyword to the global object, which is the window object. If this doesn't make sense to you, feel free to watch the previous video where I talked about the this keyword. The link is in the description. Now, let's see what will happen if we declare the inner function using an arrow function. Let's create a new function on the car object called honk. And the logic of this function will be exactly the same as the drive function, except that we're using an arrow function for the inner function. What do you think will happen now? Would we still see the window object or something else? Let's find out what will happen. Well, it turns out to be the car object. And this is exactly what I meant by binding to the parent's context. So when we're creating an arrow function, JavaScript will try to pass the this keyword in the current context to the function itself. In other words, JavaScript will try to grab the this keyword immediately right above the inner function, which happens to be the honk function in our case here, and set the this keyword of the inner function to be the same as the this keyword in the honk function. The this keyword in the honk function from our function call here would be the object itself, and that's why we see the car object in the inner function. This is a very convenient feature that the arrow function offers to us. Without the arrow function, we will need to call the bind function on our inner function if we want to bind the context to something else. For example, if I want to set the this keyword in the drive inner function to our car object, I'll just call .bind right after the function definition. Whatever we pass in inside the bind function will become the context of the inner function. So if we pass in this, which represents the car object, the inner function will now console out the car object. If I pass in a string hey, the this keyword now represents the string hey. So the arrow function is really just calling the .bind this combination for our convenience. The reason is because we almost always want to access the parent context inside an inner function. If you don't want the context to be automatically bound for you, just don't use the arrow function and stick to the traditional function and call the bind function. Alright, key takeaway for this lesson. We don't need the return and curly braces in an arrow function if the function itself is a one-liner. If there's only one argument, the round brackets are optional. Arrow function automatically binds the parent's context to itself. That's it for now, and I'll see you again in the next video. Hey there, Sam. A function can return a string, a number, an array, or an object. But what if I tell you a function can return another function? Interesting, right? So the concept of a function that is returning another function, or taking a function as its argument, is known as a higher order function. And higher order functions are one of the key pillars in functional programming. And we'll be discussing more about functional programming in a future video. For now, let's take a look at why we might need a higher order function in our code. So in general, higher order function let us write cleaner and more maintainable functions. Let's take a look at an example. Suppose we have a main element and I want to create multiple headings with different colors inside our DOM. First of all, let's target our main element so we can easily manipulate it later on. Next, I want to introduce you to new concepts. The first one is something called a factory function, which is basically a higher order function that generates or returns a function. The second concept is called closure, which is a fancy word for a function that was defined in another function. Now we'll be creating our headings using these few concepts that we just learned. So a heading has two variables, the color and also the content of the heading. The idea here is that we'll be creating a factory function that accepts the color of the heading, and the factory will create another function that creates the heading with the specified color. I'll show you what I mean. So we'll declare a new function called heading factory, and it accepts one argument, which will be the color of the heading. And inside the function, we define a closure, which is what this factory will return later on. Now this closure is where we actually create the heading. So the closure here is a function that accepts a single argument again, and this time the argument will be the text content of the heading. We're going to create a new variable, heading, which is equal to document create element h1. And we want to set the color of the heading to the color specified in the factory function. So we'll set the style attribute. The value will be color, and the color argument that we pass into the factory function. Next, we'll set the text content to the text argument, and finally return the heading as a result of this closure. Then we'll return closure as the result of heading factory. Okay, now let's take a look at how we can use this factory function. The benefit of using a factory function is that it is very flexible, and they make our code very declarative and reusable. So here, let's say I want to create a red heading. To do that, I'm going to call my heading factory function and pass in the color red to it. And let's set the result to a variable. Now let's break it down. The heading factory will return us a function. So create red heading is a function. And this function is the closure that we define inside the factory function, which accepts a text argument and will return a heading with the color red. Let's try this out. I'm going to try to call the create red heading function and pass some random text to it, and append the result to a main element. And it works. We can now see a red heading inside our browser. Let's take a look at another example. Let's create a gray heading this time, and repeat the process. And now we get a gray heading in our DOM. And every time I want a new red heading or gray heading, I just need to call the create red heading or create gray heading function over and over again, which is very descriptive and convenient. Now at this point, you might be wondering, what's the difference between this technique against a normal function that accepts color and text to create a similar heading, which looks something like this. A short answer, there's not much difference. It's really all about your personal preference. However, it does make a huge difference when you've got a complex function that has a lot of arguments and logic. By applying the techniques that we learned in the past few minutes, we can break down a very complex function into smaller bits and execute the complex logic in multiple steps, which helps in debugging and also maintenance in the long run. So that's a quick intro to closure and also higher order functions. We'll discuss more functional programming concepts in the future. Key takeaway for this lesson: higher order functions are functions that accept another function as its argument or return another function as its result. Closures are functions that are defined inside another function. In other words, a function within a function. Functional programming techniques can really help us to write more declarative and cleaner code. If we use them appropriately, our code will be easier to read and maintain in the long run. And that's it for now, and I'll see you again in the next video. Hey there, it's Sam. A function can accept a number, a string, a boolean, an array, or an object. And as we talked about in the previous video, it can also accept another function as its argument. Now, this function that we pass into another function is known as a callback function in JavaScript. And callback functions exist everywhere in JavaScript. I'm pretty sure you have seen it before. Just a quick example, if I add a click event listener to my Windows object, the function here that handles the event is a callback function. Why? Because we're passing this function as an argument to the add event listener function. And our function here will eventually execute by the add event listener function somewhere down the track. Now, let's talk about why do we need callback function in the first place. The main reason why we need a callback function is because it allows the end user to customize the logic and offers a lot of flexibility. Let's use the add event listener function as an example. The author of the add event listener function doesn't really know what you want to do when you click on an element. He can't write the logic for you, can he? Because he doesn't even know how would your website look like. And this is exactly where callback functions comes into the picture. By using callback function, we as the user can decide what to do when an element is being clicked. Now let's make this concrete. We'll be looking at how callback functions work behind the scene. Now suppose I want to do some shopping. Let's create a function for that. Our shopping function will accept one argument, the budget for our shopping. And let's say we spend $100 in our shopping trip. So our budget now will be equal to budget minus spent. And the result of this function will be the remaining budget. So far, so good. However, right now, the user who used this shopping function might want to do something after the shopping, and they don't really have the flexibility to do anything because of the way how we structure our code at the moment. So what should we do then? The answer is to introduce the callback function. So let's create a second argument for our shopping function, and I'll call it after shopping callback. So this argument will be a function that is defined by the user. And we'll run this function right before the return statement. And now let's try to use our shopping function. We'll call shopping, and the budget will be $1,000. And for the second argument, we should pass in a function. And let's say after we finish shopping, we'll go and watch a movie. So I'll just console log watch movie. Let's test our code. And now in the browser, we can see watch movie in the console. Let's break it down for one more time. So we pass in a function as the second argument of shopping. And now this function becomes the after shopping callback. And within the shopping function, we're calling this function right before the return statement. And that's where our custom function gets executed. Okay, moving on. Suppose the activity that we want to do after the shopping is dependent on the budget remaining from our shopping. Right now, there's no way for us to access the budget remaining from our shopping trip. So why don't we pass our budget to the callback function just like the other functions? So now that means, back in our callback function definition down here, we should receive an argument which represents the budget. And just like the other functions, you can name the argument to anything you like. I'm just gonna name it budget to keep things consistent. And now, if we console log our budget, we would expect to see $900. And there you go. If we compare our shopping function against the add event listener function, can you see how similar they are? And this is exactly what's happening behind the scene in every callback function. Let's finish off our shopping function. Let's say the movie cost us $30. We'll deduct the budget by $30 and return the remaining budget as the result of our callback function. In other words, the callback function will give us back whatever is remaining after the activity. So back in our shopping function, we can reset budget to the return value of the after shopping callback. And now if we set the result of our shopping function to a variable and we console log it out, we'll see the leftover after everything. And that's how some callback functions requires you to specify a return value because it needs to use that return value to do something. Okay, now there's one last thing before we end the lesson. There's a concept called callback hell in JavaScript. What that means is we're nesting callbacks after callbacks inside callbacks. If you have no idea on what am I talking about, take a look at this. Let's say we go for shopping again. Our budget is still $1,000. And inside the callback function, suppose we want to do another round of shoppings after the first shopping trip. So we're going to call the shopping function again. And let's say after the second round of shopping, we're still not satisfied because we're a bunch of shopaholics. So we go for a third round and a fourth round and on and on and on. Can you see where this is leading us to? not a shopping mall, but towards callback hell. This code here is very ugly and definitely not something that we want to do. There is a solution for this, and it is called promise, which we'll be talking more about it in the next lesson. Key takeaway for this lesson: callback is a function that is passed to another function. The idea of callback function is to allow the end user to customize the logic of a function. Callback hell is not pretty. It is very hard to read and also to debug. We should try to avoid it as much as possible. That's it for this lesson, and I'll see you again in the next video. Hey there, Sam. There are two types of operations in JavaScript: synchronous and asynchronous operations. Synchronous operations, or sync for short, are operations that run on the spot. For example, when we set a variable, or we want to console log something, these are all considered as sync operations, because when JavaScript sees them, JavaScript will run them right away. Asynchronous operations, or async for short, on the other hand, are operations that would delay their execution. For example, set timeout and set interval are considered as asynchronous operation because when JavaScript sees them, JavaScript will not run them immediately. JavaScript will only run asynchronous operations once all the synchronous operations are completed. I'll show you what I mean. So if I add another console log right after my set timeout, what do you think will happen here? What would we see inside the console? I've set the delay of my set timeout to be 0 seconds, so technically it should run immediately right after the first console log, right? Let's find out in the browser. Well, it turns out Hey Babe runs after you and there. But why is that? The reason is set timeout is an asynchronous operation, and JavaScript will only run it after all the synchronous operation. When JavaScript sees an asynchronous operation, it will throw it into a queue system known as the event loop. Let's visualize this with my amazing drawing skill. So suppose we have a list of operations here. Every item in this list represents an operation awaiting JavaScript to run. It's sort of like a to-do list for JavaScript. So we have a synchronous operation, 1, followed by another synchronous operation, S2, and right after S2, we have an asynchronous operation, 1, and after that we have another synchronous operation, S3, followed by 2 more asynchronous operations, A2 and A3, and lastly, an S4. And now let's say this is the queue system, the event loop, which looks something like a box. And now let's go through our to-do list as JavaScript. So when JavaScript sees our first synchronous operation, S1, it will run it right away. So S1, check. S2 is synchronous as well, so we'll check it off immediately. Next, we have an asynchronous operation, A1. We're not going to run it immediately, so we'll put it inside the event loop. So we'll bring it over to the box. Next, we have synchronous operation, S3. We'll do it right away. And after that, we have A2 and A3, and similar to A1, we'll bring it over to the event loop. And lastly, we have S4 in the list. We'll run it immediately, just like the other synchronous operations. Now that we have completed the list, we'll now go to the event loop and start doing the item from the top to the bottom. So A1 done, A2, and finally A3, and we're done. So that's how JavaScript deals with synchronous and asynchronous operations in a nutshell. We first finished all the synchronous operations, then the asynchronous operations. And now I want to introduce you a new concept called promise in JavaScript. A promise is another type of asynchronous operation in JavaScript. It is essentially an object that holds some sort of logic to be executed later. It works the same way as promises in real life. So when we make a promise, we won't do it right away. Our promise holds until we start to take action to fulfill our promise. Since we're not completing our promise right away, this makes it an asynchronous operation. I know this sounds a little bit abstract, but I promise I'll go through this with you. So let's make a promise to buy an ice cream. I'll create a function that accepts an argument called amount, which represents the money we're going to spend on ice cream. Now in this function, we need to return a promise. We will return a new promise. I'm using a new keyword here to create a new promise object. We'll talk about the new keyword in more details in a future video. For now, to create our promise object, we need to pass in a handler function inside the round bracket. This handler function is also known as the executor function. It contains the logic of our promise, which will be later on executed inside the event loop. Now the executor function has 2 arguments, resolve and reject. You can name them anything you want, as long as you reference them properly inside the executor function. So the resolve argument is a function that we should call when the promise is successful. On the other hand, the reject argument is a function to call when the promise has failed. In our case here, if we have successfully bought our ice cream, we should call the resolve function. Otherwise, we should call the reject function. I'll show you what this means in just a second. Now, the only rule about the executor function is that the logic in it has to be an asynchronous operation. For that purpose, we usually put our logic inside a setTimeout function. Our logic will be very simple. If the money given is less than 3, which is too little to buy an ice cream, we're going to reject this promise. In other words, this promise will fail. So we're going to call the reject function by putting a round bracket after it and passing a message. I'll just say, not enough money. Otherwise, if we have enough money, we will resolve this promise. In other words, this promise is a success. So we're going to call the resolve function. Again, put a round bracket after the resolve argument and pass in a success message. I'll just put in an ice cream. And that's how we use the resolve and reject argument. Okay, now let's take a look at how we can use our buy ice cream function. We're going to call it. I don't need to supply any argument here because the amount argument has a default value of 5. Now the buy ice cream function is returning us a promise. And there are two functions that we can call from a promise object. The then function and a catch function. The then function is used to handle the success promise response. It accepts a function where we put in a logic to tell JavaScript what to do when the promise is successful. And this function accepts an argument, and that argument represents the data that we pass in to the resolve function. So if I console.out response, I will expect to see an ice cream in the console. Now the other function, the catch function, works the other way. The catch function is where we handle a failed promise. And similar to the .then function, the catch function also accepts a function. And that function is where we put in a logic to tell JavaScript what to do when the promise has failed. So if I pass in 2 to my buy ice cream function, I will expect the promise to fail. Because 2 is less than 3, so the reject function will run, and we see not enough money in the console. The thing about the then and catch functions is that they will also return a promise object. And that's the reason on why I can call the .catch right after the .then. Because the then function is returning us a promise, and I'm calling the catch function on that promise object. So knowing this, we can chain a lot of then function on top of each other. And whatever you return in the previous then will be passed on to the next then as the argument of the handler function. For example, if I return a string, I bought an ice cream in my first then function, and I chain another then function right after it, console.out the response, change 2 to 20, and we see I bought an ice cream in the console because the string has been passed on to the next then function. If you don't like to do it this way, you can also break out the promises into multiple variables. I'll set a variable buy to be the result of buy ice cream, and buy2 to be the result of the first then, and buy3 to be the result of the catch function on buy2. However, I do not recommend you to write your promises in this way because it's very ugly. Now here's a question that you might have at this point. Does the location of the catch block matter? Can we put the catch block in any order that we like? For example, move the catch block to line 42. The answer is yes, it matters a lot. Here's the thing, the catch block is only able to capture errors that happens in the then functions before it. I'll show you an example. So if we throw an error in the first then, the catch function is able to capture it. So far so good. And line 47 is undefined because the catch handler is not returning anything. So the response is undefined. Now if we throw another error in the second then, let's see what will happen. We get an uncaught error. Nothing is catching this error, and therefore JavaScript is not happy about it. And this is what I meant when the catch function is only able to catch errors that are thrown above it. Writing a promise seems to be a lot of work involved in it. There's actually a simpler and cleaner way to write a promise. The trick is using the async keyword. Let's take a look at this. I'm going to replicate the buy ice cream function, but in a much simpler way. So I create a new function called buy ice cream 2, and instead of setting it to just a normal function, I'm going to add the async keyword before the function keyword. And inside this function, we no longer need to create a new promise object. The async keyword does all the heavy work behind the scene for us. We only need to focus on the logic that we put in inside the setTimeout function. If you want to reject the promise, we just need to throw a new error. And to resolve the promise, we just need to return the result as a normal function. Take a good look and compare between these two functions. They are doing the exact same thing, but the async function is way cleaner than the first version. Let's test our buy_ice_cream2 function. And it works just like before. Now, that's another benefit of using async function. I'm going to introduce you another keyword. It is called the await keyword. The await keyword can only be used inside an async function. And what it does is allow us to execute promises synchronously. Let's take a look at an example. I'm going to create a new async function called main. Now, to demonstrate the power of the await keyword, I'll console log out hey, and then I'll await buy_ice_cream2. So the await keyword will force the promise to resolve immediately, and the result of this statement will be the data that we pass on to the resolve function inside the promise. So if I set the result to a variable here and console log it, and after that I'll console log out another there just to show you it's running synchronously, and run the main function. And now we see an ice cream before the word there. Here's the question though, why do we see an ice cream for 2 times? The reason is the await keyword will force the event loop to run. And remember, the task in the event loop has an order to it. The promise in line 47 is put to the event loop before the promise in line 52. And that's the reason why line 47 is run before line 52. And we see an ice cream for 2 times. Now the last thing I want to cover before we end the lesson is the main benefit of using promises, which is avoiding callback hell. So in the previous lesson, we talked about how callback hell can look very, very ugly. So the weakness of callback can be easily resolved by promises. Let's take a look at the demo. I'm going to buy an ice cream. And after that, in the then function, I want to buy another ice cream. I can simply call the buy_ice_cream function again and return it. So the result of the buy_ice_cream function will be passed on to the next then. And in the next then, I'll call the buy_ice_cream function again, and so on and so forth. Can you see how this has solved the main issue of callbacks? We're no longer nesting callbacks upon callbacks, but instead, we're keeping our indentation shallow. And that is the main reason why we prefer promises over callbacks. Alright, key takeaway for this lesson. Synchronous operations run on the spot, while asynchronous operations run later in the event loop. Event loop is a name for the queue system that JavaScript uses for asynchronous operations. Promises are async operations that aim to solve the problems of callback. Async function returns promise. So instead of writing a boilerplate to create promises, we can just use this nice helper keyword before our function. And that's it for this lesson, and I'll see you again in the next video. Hey there, Sam. There are a lot of websites that has this click to copy button to help us easily copy content to our clipboard. Let's learn how to do that in JavaScript. We'll start from scratch. I'll create an article element where I'll put in some crap for JavaScript to copy later. I'll also create a button, so when we click on it, we'll copy the content in the article. Next, we'll attach a click event listener to our button. Let's store our button as a variable. And we'll call the add event listener function with the click event. And here, when we click on the button, we want to get the text content of our article. So we'll target our article ID, content copy, and grab the text content property. Once we get the content, we'll need to find a way to write the content to our clipboard. The browser does offer us a very simple way to work with clipboard content by using the built-in clipboard object. And similar to the console object, the clipboard object is also one of the available tools in the browser. The documentation link is provided in the description below, so feel free to check it out after watching this video. The clipboard object is a sub-object of the navigator object. So to use it, we need to call navigator.clipboard. And to write content to our clipboard, we'll call the writeText function. And the writeText function accepts one argument, which is the content to be put into the clipboard. And now if I click on the button, I will expect the content in the article to be copied to my clipboard. And I'll paste it in my VS Code. And we see the crap. So far, so good. Now let's learn how to read content from the clipboard. To read the text content, we simply call the readText function. And we'll console log out the copied content and click on the button. Oh no, there's something going on here. So there are 2 things I need you to be aware of. 1. For security reason, access to the clipboard is blocked by the browser by default. So the user need to explicitly allow a website to access their clipboard by clicking on this button. Why do we need this? Because we copy sensitive data like our password or credit card number all the time. If we happen to visit a malicious website while having our credentials stored in our clipboard at the same time, that would be a massive disaster. Now the second thing is the read text and the write text functions are promises. So that means they are asynchronous. So to read the text content in our clipboard, right after we copy it, we either need to use the then function or use the await keyword. I like the await keyword better, so let's use that. To use the await keyword, we first need to turn our function into an asynchronous function by adding the async keyword before our function definition, and await the write text function and also the read text function. And now we're seeing our copied content is printed out in the console, which is great. We can also paste images from our clipboard. Let's create a new article element for us to paste in an image and also a paste button. And similar to the copy button, we'll also store the paste button as a variable and add an event listener to it. When we click on the paste button, the idea is we'll read the content from the clipboard and paste them into the article. So first, we need to store our article as a variable. And we should clear the content of it when the paste button is clicked. Now, to get non-text content from the clipboard, we need to call the read function on the clipboard object. Again, the read function is a promise, so we should use the async and await keywords again. Now, the data returned by the read function is an array of clipboard items. To get a clipboard content, we need to retrieve the first element of this array. Now, the clipboard content belongs to the clipboard item data type. It has a few helper functions that allow us to grab data from the clipboard. To get image data, we can call the getType function from it. The getType function accepts one argument, which is a string that represents the file type. This type of string is also known as the MIME type. It's using a convention of file type / extension type. If you want to take a look at the other MIME types, I have attached a link in the description below. So the getType function is also a promise, so we should put an await before it. And it'll return us something called the blob. Blob stands for binary large object. To put it simply, it is just a giant string that represents a file. Our goal here is to put this blob inside an image tag so we can show it in the browser DOM. The blob is stored inside a temporary location in the browser. So first of all, we need to grab the URL that points to the blob. To do that, we can call the windows.url.createObjectURL function and pass in the blob object. That will create an image element and set the source attribute to the blob URL. And finally, append our image element to the article. Let's test our code. I'll go to unsplash.com and randomly copy an image and click on the paste button, and it works. However, at the moment, our code could fail. Why? Because if the content in our clipboard is not an image, JavaScript will explode. I'll show you what I mean. So if I click on our copy button, which will copy the text into our clipboard, and I click on the paste button and see that, that's an error. We can easily fix this by using a try and catch block. So I'm going to try to capture any errors that was thrown inside our image handling logic. If that's an error, that means we cannot copy the image. So we're going to call the read text function instead and set the text content of paste article to the text. Let's try our code again. We paste the text in and we see the crap. And if we copy the image from Unsplash, paste it in, and the image is showing. And that's it. Key takeaway for this lesson. The built-in clipboard object allows us to manipulate the clipboard with JavaScript. Blobs, or binary large objects, represent file as an object, so we can work on them using JavaScript. You can convert pretty much anything into blobs, including images, PDFs, or even videos. MIME type is a string convention to describe a particular data type. That's it for this lesson, and I'll see you again in the next video. Hey there, Sam. API or Application Programming Interface is a scary word for a very simple concept. The word interface here has a huge weight in the meaning of API. Let's explain API starting with the word interface. So what is an interface? An interface is a point of interaction or a tool for us to work with a much more complicated system. For example, a computer is a very complicated system for us average human to understand. However, in order for us to work with a computer, we don't really need to understand the inner working of a computer. That would be too much to learn. Instead, all we need to know is to learn how to use the keyboard and mouse for us to interact with the computer. The keyboard and the mouse are relatively simple compared to the computer system. And that is exactly what an interface is. A simple tool to work with or interact with a much more complicated system. Let's take a look at another example. A car. Similar to a computer, a car is also very complicated for us average human to understand. So to make our life easier, the car manufacturer has made available a few interfaces for us to drive a car. For example, a steering wheel, a gearbox, the indicator handle, and a speed pedal. With these interfaces, we can interact with a car without knowing the inner working of a car. Now, API is exactly like these interfaces. The only difference is, an API is an interface to a computer software. So if a software has an API, we don't really need to know the inner working of the software, but only need to learn the API provided for us to interact with the software. In other words, API are just a set of functions provided by a software for us to interact with it. Generally, there are two types of API, Programming API and Web API. Let's take a look at a few examples to make this concrete. So Programming API is just really a set of functions that we can use directly in our programming language. I'll show you what I meant. The browser is a large piece of software that has lots of components in it. Just name a few examples. We have the console, the DOM, and the local storage. We can think of each of these individual components as separate software. And the browser does offer us ways to interact with these components. In other words, the browser offers us a programming API for us to interact with these components. And we have seen it lots of times already. For example, to work with the console, we simply just need to call the console functions. Console.log or console.error are functions that we can call on the console object. In other words, the API of the console. To interact with the DOM, again, we are calling functions from the document object. And again, all the functions that are exposed by the document object are the API of the DOM. And we're using these APIs directly in JavaScript. That's why it's called the Programming API. If you want to take a look at all the available APIs offered to you by the browser, you can go to the Web API documentation and check out all these APIs available to us. The link is in the description. There are lots of interesting APIs here. For example, the Bluetooth API, where we can let the browser to interact with Bluetooth on our device. Imagine you can remote control a toy car using a browser. How cool is that? The geolocation API is another interesting one, where we can get to know the location of our website visitor. So applications like Google Maps or Uber will have relied on this API to get to know the user's location. That's enough for Programming API. Let's move on to Web API. Have you been to some website where you can share some posts directly to your Twitter account or your Facebook account, or a website that has Google Maps embedded in it? They are not owned by Google, Facebook, or Twitter, but yet they are using these third-party services on their website. And if you're wondering how they did this, it is through the magic of Web API. There are millions of web applications out there, and the majority of them are closed source. That means their source code is not open to the public, which means we can't interact with them directly in our programming language, and therefore there's no Programming API available to us. So what should we do then? There are typically two ways for us to interact with a web app. The first way, which is obvious, is to use the user interface provided by the website. The second way is to use Web API. As we mentioned earlier, APIs are essentially functions exposed by a software. In contrast to Programming API, where we run these functions directly in our programming language, for Web API, we'll be running these functions through HTTP. Before we dive in any deeper, let's first look at what is HTTP and how it works. HTTP stands for Hypertext Transfer Protocol, and again, it's a scary word for a very simple concept. We humans have lots of ways to communicate with each other. When we want to talk to our friends, we can either call them by phone, or send an email, or text them. And similar to humans, computers can talk to each other by different ways as well. And HTTP is just one of the ways. The other methods include SSH, FTP, and GET, and many others. Each of these communication methods involves different rules and procedures. Just like how when we make a phone call, we gotta use a phone and dial the other person's number. Or when we text someone, we need to type our message out. Now let's go through HTTP in more details. Suppose this is a computer that you're using right now. And this is a server that sits somewhere in the internet. And now suppose your local machine wants to talk to the server via HTTP. The HTTP rules says that your local machine will send out a request to the server, and the server will reply with exactly one response. So with one request, we're expecting to get back one response. Nothing more, nothing less. Now, for both request and response, each of them has two components, the header and the body. The header contains metadata about the HTTP request or response. For example, the content type, or the language, or the origin of the request or response. If this doesn't make sense to you, don't worry. We'll go through a real-life example later. The body contains the payload. For example, if I was to log into a website, my request body will contain the credentials, and the response body will be a message telling me if my login attempt is successful or not. HTTP request has different types of methods, or flavors if you like, to accommodate different types of operations. The most common methods are get, post, patch, and delete. The method is typically specified in the header of the request. A GET request is generally for downloading, reading, or viewing resources. For example, downloading a HTML document to render in a browser, or getting an array of users' Facebook posts. Post request is for creating new resources, or for any miscellaneous operations. For example, creating a new user account, or a new Facebook post, or simply log in to a web application. A patch request is for updating resources. For example, when we want to update our Facebook post, or comment, or our profile picture. A delete request is self-explanatory. Whenever we want to delete resources, we'll just send a delete request. Now let's take a look on how HTTP works in action. We'll go to Google with the Chrome developer tools open, and we will switch to the Network tab. This is where we can investigate all the HTTP requests happening inside the browser. Make sure you selected the All filter to view all the HTTP requests. There are other types of filters available to us to filter out different types of HTTP resources. Now that you'll notice there's a list of resources going on here. These are the HTTP requests that have been sent by the browser since the page was first loaded in chronological order. We can click on each individual item to investigate the request in more details. Let's go with the first one. The headers tabs here tells us more about the headers in our request and response. So if we scroll down a little bit more, we'll actually see what's inside our response header and also our request header. You'll see a lot of scary stuff here, but don't worry, you do not need to learn all of them at once. We just need to know a few of them in order to understand HTTP in general. So under the request headers, we have methods. It's a GET request, which means the current request that we're investigating at the moment is a GET request. And remember, a GET request is for downloading, reading, or viewing data. So in this case, if we go to the response tab, we see a HTML document. That means we're downloading a HTML document from Google's server. And if we go to the preview tab, we will see the rendered version of the response. So Chrome will render the HTML document right inside the developer tool. But you'll notice this is a little bit different to the one that we're seeing in the browser now. The Google's logo is missing. The icon is missing. Why is that? The reason is, at the time when this HTML document is downloaded, we only have an image tag inside the document that's pointing to an external image file somewhere in the internet. So at the time when the browser tries to render this page, and when it sees this image tag, it will then send another GET request to grab this image file. And once this GET request for the image file is completed, then the browser will put this image inside the DOM. The same applies to all the JavaScript files, CSS files, and so on and so forth. And that's the reason why we're seeing all these resources loaded inside this list. The first item is always the main page, and the subsequent requests are the items that is required by the main page or sent out by the JavaScript file of the website. So if we try to click on the other request, we'll see my account avatars, the Google's logo, and lots of icons. And again, all these requests are fired by the main page. And they're all GET requests because we're just downloading files or resources from another server. Let's take a look at another example. We'll go to this website, CodePen.io, and I'll try to log in with some garbage credentials. Now notice very carefully at the request list as I hit the login button. A new request has been added. Let's take a look at it. First of all, it's a POST request rather than a GET request, because right now, we're no longer trying to download something from the server. We're trying to perform an action. And remember, POST request is for creating new content or any other miscellaneous operations, like login. And if we scroll to the very bottom, we can actually see the payload of our POST request. These are the body of this POST request sent to the CodePen.io server. And they matches with what I entered in a text input of the website. If we go to the response, we're now seeing a JSON response rather than a HTML document. Let's go to the preview tab to look at the pre-printed JSON string. So this is what the server has sent us back when we entered a garbage credentials. It tells us the username and password is incorrect. And notice that the error message is exactly the same as what we see in the user interface here. Okay, let's break the whole process down and go through this together. So here's the server, and it has lots of predefined URLs that are listening to incoming HTTP requests. Each of them has their own roles and responsibilities. Sending a HTTP request to each of these routes will trigger a function in the server to perform some sort of task, and when the task is finished, the server will send back a response to the browser. Can you see where this is going now? We can let the user to run a certain functions on the server without even letting them to look at the code. This is exactly how a web API works. We are running functions on the server by sending a HTTP request to a certain URL or endpoint, and the server will send us back the result of the function. One thing to note here is that different HTTP methods could have different behavior on a certain endpoint. For that, you'll need to consult the documentation provided by the application's developer. For example, if we send a GET request to the login endpoint, the server might run a function that will return us a HTML document back. However, if we send a POST request to the login endpoint, the server will trigger a different function this time. It might take a look at the request body for the credentials, look up in its database, and try to find the matching credentials. If it found one, then the user is authenticated. Otherwise, the server will throw us back an error in JSON format. All of this behavior of the endpoints are all predefined by the author of the application. So if we want to use a web API provided by an application, the first thing to do is to read through the documentation and go through all the endpoints and see what they can do. Let's take a look at an example now. We'll be looking at GitHub's API. Going through the documentation here, we can get a list of open source licenses from their API. As we can see here, it's a GET request. I'll just copy the link here and paste it inside the browser's URL bar. By default, the browser will perform a GET request on the URL that we entered in the URL bar. And now we're seeing a JSON string returned back by the API endpoint, which is an array of licenses. If you're using the Chrome browser, you might not be seeing this pretty printed JSON string out of the box. I'm using this extension called JSON Formatter to do the job for me. The link is in the description if you're interested. Now there's one last thing I want to go through before we end the lesson, which is the concept of HTTP codes. You might have already noticed this already. Whenever we send a request to a server, there is this thing called the status code being returned back in the response header. The status code is also known as the HTTP codes, and as a convention, we normally use these codes to indicate whether a HTTP request is successful or not. If you go to this website, you can take a look at all the standard HTTP codes that are used in the internet today. Just a quick overview. The 200 series normally means success, without any errors. The 300 series normally means redirection, where the server wants to send us to a different web page. For example, after we logged in, the server might want to send us to the app dashboard, and in that case, the server will return us a status code of 302. The 400 series normally means there's an error within our request. It could be our endpoint is misspelled, or the payload is incorrect, or we are unauthenticated. The 500 series means there's a bug on the server side, and there's usually nothing we can do when we see this error, other than contacting the site's owner. I hope it makes sense so far. We'll be building a very simple app in the next lesson using Web API and JavaScript. I'll see you there. Key takeaway for this lesson: APIs are just functions exposed by a software, where we can use the API to interact with the software. Programming API are consumed within the programming language itself. We call the functions directly inside the code. In contrast, Web API are consumed via HTTP, where we don't have access to the source code of the software by using HTTP requests to trigger functions of the software. HTTP comes with two parts, the request and the response. The browser will send a request to the server, and the server would reply back with a response. And both of the request and response would have a header and a body. The header contains metadata about the request or response, while the body contains the payload. Hey there, it's Sam. So in the previous lesson, we learned about API and HTTP, but we haven't really gone through how to use API in JavaScript yet. Here's the app that we'll be building by the end of this lesson, using Web API. This is a very useful app for us to answer yes or no questions. Let's try it out. We'll ask a question, and the computer will decide for us. Let's try it one more time. Bam! We get a no again. Okay, let's give it another try for one last time. Damn, it is smart. So before we dive into the code, I want to quickly introduce you on how to send out HTTP requests using JavaScript. So that's this API here that will fetch us all sort of information about the latest status of COVID-19 across the globe. And here's the documentation. The link is in the description if you're interested. Let's use this API for a little demonstration here. We'll try to call this country's endpoint. So I'll copy this link, and now let's go to VS Code. We'll create a new variable for this API endpoint. The browser has offered us a very simple way to send out HTTP requests using the fetch function. The fetch function accepts two arguments. The first argument is the API endpoint, so I'm going to pass in URL in there. And the second argument is the option for our API request. So the options include the method of our HTTP request, which in our case here will be a GET request. So I'll just need to put in the string GET. We'll also put in the headers, which will be telling the server that we only want to accept JSON response. There are other options available. The documentation again is attached in the description below. Now the fetch function is an asynchronous operation and it will return us a promise. So to handle the response, we'll need to call the .then function on the promise. And the callback function accepts one argument, which is the raw response of the API, represented by a special response object. We know that this API is returning us a JSON body. So to read the response object in JSON format, we'll need to call the JSON function on the response object. The JSON function here, again, is returning us another promise, and we'll pass a result to the next then. Let's console log out the response, and we'll see it inside the browser. And we get a massive array with 248 elements in it, which is the expected API response, as written in the documentation. And from line 21 and onwards, it will be up to us to do whatever we want on the data that we got from the API response. The possibilities are endless. We could build a chart to display all this data, or to build a travel app that indicates how safe a country is if we were to travel to there. Okay, now that we know how to use a fetch function, let's build our decision-making app. First of all, let's put down our layout. We'll need a form for the question input, and we'll put down a label and the input element with an ID of task. And inside the label, we'll put down the heading for our input. Let's see how it looks like in the browser. Looking good. We'll put in some placeholder for the input field as well. Our form is aligned to the left at the moment, which is not that great. Let's center it with Flexbox. We'll create a few helper CSS classes. Deflex to set the display property to flex so that we can create a flex container. Justify center to center items on the main axis. Flex code to set a flex direction to column. And align center to center items on a cross axis. And now let's apply our helper classes on the form. We'll make it a flex container and set a flex direction to column to align the items vertically. And then we'll apply our align center class to center the items on the cross axis, which is on the horizontal axis. Let's test it. Looking great. After the form, we need a place to display our result. We'll create a new section and give it a class of image container. Within the section, we'll put an article to display the yes or no image. And after that, we'll have a H1 to display the word yes or no. And that is our basic layout. Let's start writing our JavaScript now. Before we move on, let me show you the API that we're going to use in this app. It's a website called yesno.wtf. So the idea is, every time we refresh the page, this website is going to give us either yes, no, or maybe, depending on our luck. And if you look on the lower left corner, they do provide us an API, which is exactly what we're going to use in this lesson. So this is a GET request with the URL of /API. Let's store this URL as a variable in our script so we can reference it later. Next, before we start coding, let's write down our story, or the pseudocode for our app. Here's the plan. When the user types in a question in the input and hit enter, we should then call the API. Once the request is completed, then we'll display the result in the image article and the answer text element. So first of all, let's add an event listener to the form element. We'll listen to the submit event and we'll create a handler function called decide. Inside the decide function, the first thing we want to do is to call the prevent default function to stop the page from refreshing from the submit event. Since we have an input inside the form element, every time the user hit enter, it will trigger the submit event on the form, and that will trigger our decide event listener. Next, we'll try to call the API. So I'm going to call the fetch function and pass in a WTF URL with some options. Method will be get, and headers will be accept JSON. Next, in the then function, we will retrieve our API response and store it inside a variable called result. Response.json is returning us a promise, and we're using the async and await keyword here to make our code a little bit cleaner, so we don't need to change the result to the next then. The result object contains 3 fields: answer, false, and image. We should put the image property inside an image element and load it to the DOM. So let's create an image element, set a source attribute to the image property in the result, and put it into image article. We also want to put the answer property into the answer text element. So let's do that as well. Alright, let's test our code. Whoops, I've got a typo there. Let's try it one more time. Boom, it's working. Let's give it another try. And that's an issue. The new image is appended to the DOM without clearing the existing image. Let's fix that. So before we call the API, we should really clear out any existing content within our image article element and the answer text element. We can do that easily by setting the inner HTML property to an empty string. And now it's working fine. But it takes a few seconds for us to get the result from the API. In other words, the user needs to wait for a few seconds after hitting enter on the input field. Let's set up some sort of loader during the waiting time. I'll put in a new article element and have a heading says let me think in there. And by default, we should hide this element. So let's create a new class called hide. And I'll set the display property to none. Next, we'll create some helper function to show this thinking element or to hide this thinking element. In the show thinking function, we'll simply remove the hide class from the class list of thinking article. In contrast, in the hide thinking function, we'll add the hide class to the class list of thinking article. And then, before we call the API, we should call the show thinking function to show the loader. And when the API call is finished, we'll then call the hide thinking function. Let's test our code. And the thinking heading is showing. Functionality-wise, our app is completed, but it looks very ugly at the moment. Let's style it. First of all, let's change our background color and also the font. We'll target the body element, change the font family, and make a dark theme background with white text. Next, we'll style the input. First of all, change the background color to transparent, and we'll give it a default border of 1 pixel solid. And we'll set the font color to this grayish purple, and set the font size to large. Give it a little bit of breathing space by setting the padding to 10 pixel, and also increase the width to 500 pixel. When the input is focused, we also want to increase the border width and change the border color to slightly lighter. And also remove the outline. Next, we should make the result center and also the thinking loader center. To do that, we just need to add our helper classes to the image container element. Set it to flex and also justify center. Working great. But now we do want our answer text to sit on top of our image. To do that, we can make its position absolute. And set the position of our image container to be relative, so the absolute position of answer text is relative to this image container. And we'll also make the answer text uppercase by setting the text transform property to uppercase. Let's test our code. Working great. And one last thing, let's just add a little bit of space on the top of our image container. I'll set margin top to be 50 pixel and give it a final run. Everything looks great. So that's a quick intro on how we can send API requests in JavaScript using the fetch function. It is a very useful function, and we'll be using it more in a future lesson when we get to learn to build our own API server. If it doesn't make sense to you, feel free to rewatch the video or visit the documentation. The link is again in the description. Key takeaway for this lesson: we use the fetch function to send HTTP requests in JavaScript. The fetch function accepts two arguments. The first argument is the API endpoint, in other words, the URL that we want to send the request to. The second argument is an object that represents the options related to the request. The fetch function returns us a promise, which means it is an asynchronous operation, and we should call the .then function to handle the response of the API. That's it for this lesson, and I'll see you again in the next video. Hey there, Sam! Sometimes we just want to test a certain API or play around with the API as we read through the documentation. But do we really want to go through all the trouble of going to our code editor, writing the fetch function, and finally running our JavaScript in the browser? Personally, I think this is just way too much of work, just because I'm a lazy, aka efficient person. So let me introduce you a better way to do this. There's an app called Postman that will solve our problems in just a few clicks. Let's download the app and run it. The link is in the description. Once you sign into the app, this is probably the first thing that you will see. It looks very scary, so let's just click on the close button, and then you'll see the screen. And this is where we'll spend most of our time on, in Postman. So here we can select our request method, the API endpoint, and the configuration of our request. We can put in any parameters that we want to send along with our request, the authorization type, the request headers, the body, or write a pre-request script for people who want to automate some task. And the test panel is for automation again, which is for advanced applications, and we won't be looking into it in this lesson. Now, let's try to send our very first API request. Let's type in google.com in the URL bar. So now we're sending a GET request to google.com, and we get a HTML document back in the response body. We can select the pretty printed version, where Postman will highlight the syntax, and the raw version, which is just a plain response from Google. And preview will be the rendered version of this HTML document. Postman also allows us to investigate the cookies and headers of the response. All the data is listed in here. Let's take a look at a more concrete example. Here's the COVID API that I introduced to you in the last lesson. The link again is in the description if you want to take a look. Let's pick an API endpoint that accepts parameters. This endpoint here will get all COVID cases for a certain country. And this endpoint accepts two parameters, the from and to parameters. The from is the starting date, and to is the ending date of our data. Let's try to call this endpoint in Postman. I'll copy the main URL without the parameters and paste it inside the URL bar. Now I'll put in the from and to parameters according to the documentation. Click on the send button. And now we see an array of data returned from the server. Let's try to change the from and to date and see if that's working. And the data now returned back is now based on the to and from dates. If we want to test different types of HTTP methods, remember, we just need to select the corresponding methods from the drop-down here. So that's a quick intro to Postman. It is a great tool to test out API and investigate the responses. Key takeaway for this lesson: Postman is a wonderful HTTP client. We can use it to send HTTP requests to test out different kind of API endpoints. That's it for this lesson, and I will see you again in the next video. Hey there, Sam. Suppose we have an object called car here, and we'll set the color to blue. Now let me create another car, and I'll set it equals to car1. And I'm going to change the color of car2 to red. And if I console log out car1 here, what do you think you'll see inside the console? Would the color of car1 to be blue or red? Pause the video for a bit and make a choice. So the answer is, surprisingly, red. What is going on here? So it turns out that in JavaScript, objects are references rather than the data itself. I'll show you what I mean. So behind the scene, JavaScript stores data in a space called the heap, and the heap is located inside our computer's memory. You can think of the heaps as a bag that holds all sorts of data. And this is where things becomes a little bit more interesting. So when we created our car1 object just now, JavaScript will store the object inside a heap. However, the variable car1 is just a reference pointing at the object that is stored inside the heap. Car1 is just a reference. It is not the object itself. So when we created our variable car2, we're essentially making a copy of the reference. So car2 is pointing at the original object inside the heap as well. That means any changes that we made towards car2 will affect the original object directly, since it's just a reference pointing at the object. So that's the reason why, when we change the color of car2, the color of car1 changes as well, because both variables are pointing at the same object. This is a very dangerous behavior and can cause very nasty bugs in our program. So how can we solve this then? There are two ways that I can show you. One is to use the object_assign function. The object_assign function accepts two arguments. It will merge properties from an object to another object. The first argument is the target object, and the second argument is the source object. In our case here, in order to break the reference link or to clone the object, we'll need to create a new object. So for the first argument, I'm putting in an empty object. And the second argument will be car1. So the object_assign function will copy all the properties inside car1 over to the new object that we're creating. And now the variable clone here is a reference pointing towards the new object rather than car1. So now let's try to change the color of the clone object to black. And we're going to console out car1 again. Now notice that the color of car1 remains as red. And that's a proof that we have broken the reference link. Cloned and car1 are no longer related. The second way is to use something called the spread operator. The spread operator is used for unpacking array and objects. Let's see how we can use it in our case here. We're going to create a new variable, clone2, and it has to be a new object, of course, because we want to break the reference link. And the content of our new object here should be the same as car1. So let's use a spread operator to unpack the content of car1. So I'll put a triple dot, which is the syntax of the spread operator, and car1 right after them. And this will unpack car1 into our new object. And now if we change the color of clone2 to green and console out car1 again, we still see car1 has the color of red. So that's a quick intro to object and references in JavaScript. Be extremely careful next time when you want to copy an object. Now let's talk about the spread operator more. The spread operator can be used upon arrays as well. Spreading an array means unpacking the array. For example, I can unpack an array to pass the elements of the array as the arguments of the function. For example, this line of code is equivalent to this. Another use case of the spread operator is it allows us to join arrays together in a very clean way. So suppose we have two arrays here with different numbers, and I want to join both arrays together into a third array. What I can do is to create a new variable, array3, and inside the array3, I'll unpack array1 and array2. So if I console out array3, I will get the combination of array1 and array2. And similar to array, we can use this technique to join objects together. So let's say we have an object1 with a property hey in there, and another object with a property hey as well, and also a food property. And now we'll create an object3, which will unpack object1 and object2. And we'll console out object3, and we see the hey property and the food property. Since object2 is unpacked later than object1, and both of them has the same property called hey, object2 will overwrite the hey property in object1. Now the spread operator has another form called the rest operator, and is only used in functions where we want an arbitrary numbers of arguments. Let's take a look at an example. Suppose we have a function called add, and this function takes in two arguments, x and y, and it will return x plus y back. It is not very flexible at the moment because we can only put in two numbers each time when we want to use this function. We might want to do something like this, where the user can put in all the numbers in one go. And here's where the rest operator saves our day. The rest and spread operator share the same syntax, but their meaning is very different. Spread is for unpacking, rest is for joining. And the triple dot will only become a rest operator when you put it inside the function's argument definition. Let's modify our add function so it uses the rest operator. In the round bracket, I'll put in triple dot and the argument name that represent the arguments passed to this function. The rest operator will pack out the arguments and turn them into an array. So if I console out nums, we will see an array of numbers. To complete our add function, I'll just write a simple for loop that loops through the numbers and return the sum. And that's it. Now we can pass in any numbers of arguments to our add function, and it will always work. Key takeaway for this lesson: JavaScript stores data in heaps, and heaps is just a location inside the computer's memory. Objects are references in JavaScript. To make a copy of the object, we should clone the object by using a spread operator or the object assign function. Triple dots are both the spread and rest operator. The spread operator is used to unpack arrays and objects. On the other hand, the rest operator is used to pack functions' arguments, so we can write functions that take in an infinite numbers of arguments. That's it for this lesson, and I'll see you again in the next video. Hey there, Sam. Suppose we have an object called car here, and it has a few properties: brand, name, and color. Now, if you want to extract these properties into separate variables, one way of doing this is to create them line by line, which is pretty tedious. Is there a better way of doing this? Yes, and it is called object destructuring. Let's see how it works. So here's the syntax. If we just want to extract the brand property out, we'll put it inside the curly braces on the left-hand side, and to the right-hand side of the equal sign, we'll put our car object there. So now if we console out brand, we'll see Toyota. If we want to extract the other properties out, we'll just put a comma right after brand. So can you see how this single line of code is replacing what we had before, from line 16 to 18? It is nice and clean, right? And if for some reason we want to change a variable name into something else, we can just put a colon after our key and put our new variable name there. And now JavaScript is showing us an error because the variable brand does not exist anymore. And now if we console out brand123, it will print out Toyota again. We can destructure array as well. Suppose we have a fruits array, and if I want to extract the first two elements out, this time I'll put in a square bracket instead of a curly bracket, and assign my variable names inside a square bracket. Now apple would represent the first element, and orange would represent the second element. And if we console out apple and orange, we see the corresponding fruits string in our fruits array. Just to be clear, you can name your variable to anything you want. It doesn't need to match the content of the array. I'm keeping them the same just for demonstration only. So if I rename my first variable to apple1 and console it out, it will still work as before. Array destructuring is a very useful technique if we just want to grab the first or second element of an array. If we want the remaining elements to be packed into a new variable, we can use the rest operator to achieve this. For example, let's add a new fruit, grape, to the end of our array. And right after I destructure apple and orange, I can pack kiwi and grape together into a new variable called other by putting the rest operator in front of it. So now if I console out other, I'll get an array containing kiwi and grape. We can also skip an element by not assigning a variable while we're destructuring the array. For example, if I want to skip orange, I'll just remove my orange variable. Now the other variable still represents kiwi and grape. One of the most useful applications of array destructuring is it allows us to swap variable very easily. So now let's say we have two variables, A and B, and I want to swap the values around. Traditionally, if I want to achieve this, I have to create a temporary variable and assign it to A, then swap A with B and B to temp, which is pretty tedious. However, with array destructuring, I can achieve this in just one line of code. So here, I'm destructuring the array on the right-hand side, A and B, into the variable B and A. So now I'm reassigning the variable B to be the first element in the array. In other words, I'm swapping B with A. And the same goes with A and B. And that's a quick intro to array and object destructuring. Key takeaway for this lesson: object destructuring is useful to extract properties out. Array destructuring is useful to extract the first few elements out from an array. Using this technique, we can easily swap the values of two variables in just one line of code. That's it for this lesson, and I'll see you again in the next video. Hey there, Sam. When it comes to programming, there are three types of paradigm: procedural, object-oriented, and functional. In the early days of programming, there's only procedural-styled programming. Procedural code are written as step-by-step instructions. For example, declaring a variable and writing an if statement here are procedural because we're just writing down the instructions in sequential order without any fancy magic. Although procedural-style programming is simple, it does have its shortcomings. Procedural code is very verbose. That means it's very explicit because we need to write down the step-by-step instructions in a very detailed way. And that makes procedural code very hard to read and lengthy, which is not very convenient for us humans to read and understand the code. It is also very hard for us to reuse procedural code. If we want to apply the same logic in multiple places, in a lot of time, the only way to do this is to copy and paste, which is a big no-no. So programmers eventually came out with a new paradigm called object-oriented programming to solve the issues of procedural programming. Now, in object-oriented programming, as the name suggests, everything is based on objects. So now instead of writing step-by-step instructions in one place, we will delegate or separate the task into smaller chunks and put them into entities called object. In other words, we're hiding the programming logic within object, and this concept is called encapsulation in object-oriented programming. So by splitting our logic into smaller modules, it helps us to reuse and maintain our code better in the long run. If something breaks, we would know which object is causing the problem, and we would just need to fix the logic inside that object, rather than going through a few thousand lines of code and find out which line is causing the problem. We actually have seen object-oriented programming in JavaScript a lot of times already. For example, the console log function. This is a perfect example to demonstrate object-oriented programming. So the log function is living within the console object, and the console object is a built-in object provided by JavaScript. When we use this log function, we don't really need to care about how it was implemented. All the logic is hidden within the console object. As the user, all we need to know is that the log function will print out a line in the console, and every time we need to log something in the console, we just need to call this function from the console object over and over again. In other words, we can easily reuse this function across our program. Another example would be the getItem function from the local storage. Again, the getItem function is just a function that lives within the local storage object. We can keep reusing this function wherever we want without worrying about how it was implemented inside the local storage object. Can you see the benefit of object-oriented programming now? By hiding the logic within objects, we can abstract away the complicated logic and just worry about how do we interact with these objects. And it will make our code looks very clean and easy to read. The third paradigm, functional programming, relies very heavily on functions, as the name suggests. In functional programming, we describe our programming logic using functions, and the code will read very much like English. Functional code is very declarative. That means just by reading the code, we will know the intention right away. I'll show you a quick example. So suppose I have an array of fruits here, and I want to convert every one of them into uppercase, and then filter out the fruits that has less than 4 characters. To achieve this in functional programming, we'll call some of the JavaScript array helper functions that use functional programming techniques. First, I'll map each fruit into uppercase. Once I'm done, I'll call the filter function on the result and filter out all the fruits that have more than 4 characters. Now looking at this code, it reads a lot like English, right? And it tells us what it's doing in a very declarative way. Again, we're simply mapping each fruit or converting each fruit into uppercase, and we're doing a filter where we tell JavaScript we only want the fruit that has more than 4 characters. And that's the whole point of functional programming, creating meaningful function so our code will be easier to read and cleaner. If we were to achieve the same in a non-functional way, let's compare how it would look like against functional programming code. First, I'll create an empty array to store our result. Then I'll have a for loop to loop through the fruits array. And in each loop, I'll check the length of the fruits if it is greater than 4 or not. If yes, then we'll push the uppercase fruit to our result array. And now let's just stop here for a few moments and compare these two blocks of code. The lower block is much more verbose than the upper block, and we have to read and try to interpret it before we can understand the context of this code, while the functional programming way tells us right away what the code is doing. And that is the power of functional programming. We are writing cleaner and clearer code. And just one more time, procedural programming is where we write our logic as step-by-step instructions. Object-oriented programming, OOP for short, hides logic within objects, and we call it encapsulation in programming terms. Functional programming, or FP, describe the logic using functions. Now at this point, you might be asking, which paradigm does JavaScript belong to? The answer is, surprisingly, none of them. JavaScript is a very unique language. It is actually based on something called the prototype. We'll be discussing more about the prototype in a future video. However, JavaScript is a very flexible language, and it does support the functional and object-oriented style of programming. And in the next few lessons, we'll be looking exactly on object-oriented programming in JavaScript. So I'll see you there. Key takeaway for this lesson: procedural programming is about writing logic as step-by-step instructions. Object-oriented programming, OOP for short, is about splitting the logic or task into modular components known as objects, so that we can easily reuse our logic. Functional programming relies heavily on functions, and we describe our logic using functions. JavaScript is a prototype-based language. However, it does support features in object-oriented programming and functional programming. That's it for this lesson, and I'll see you again in the next video. Hey there, it's Sam. As we discussed in the last lesson, object-oriented programming is all about encapsulating our logic within objects. Now, suppose we want to create a few cars. We'll create an object called Toyota and give it a name property, a brand property, and also a drive function. And now if I want to create a second car, I'll have to write out all the properties again. And if I want to create the third, the fourth, the fifth car, things will become tedious very quickly. It would be great if we can create a template that will create a car for us, so we don't have to write everything from scratch. Is there such thing in JavaScript? The answer is yes. And the template is called class. Let's learn how to create a template for our car object now. To create a class, we first start with the class keyword, followed by the class name. And as a convention, we would capitalize the class name. So next time when you see something with a capital case, it's very likely that it is a class, and we can create an object out of it. After the name, we'll put a curly braces. And this is class in the most basic form. And now to create an object out of this class, we're going to use the new keyword. So let's create a new variable and set it equal to new car. The new keyword will create a new object out of the class. And we refer this process as instantiating a new object out of a class. And we refer Suzuki as an instance of the car class. Let's complete our car class. Now to give a default property to the object instantiated from this class, all we need to do is to type out the property name and set it equal to some value. And now if we console out Suzuki.name, we should see a car in the console. And there we go. However, we don't want default value. We want the ability to customize the name of the car when we create an object out of a class. And this can be done using something called the constructor function. In short, the constructor function is a special function that will run every time we created an object out of a class. To define a constructor function, we simply need to type in the word constructor, followed by a round bracket and curly braces. And just for demonstration, I'm going to add a console log inside the constructor. And now we see creating a new broom in the console, because the constructor function runs when we created our Suzuki object. Now the constructor function can accept arguments. Let's make it accept two arguments, name and brand. And we supply the value to these arguments at the time when we created the car object. So the name will be Swift and the brand will be Suzuki. And now back in the constructor, I'll console log out name and brand just for demonstration. And we see Swift and Suzuki in the console. Now using this behavior, we can customize the property of our object instance, because now when we create a new car, we can pass anything we want as the argument to the constructor. We just need to reset the name property to the argument supplied. To do that, we'll use the this keyword. The this keyword in any function inside the class represents the object instance created from this class. So in our case here, the this keyword would represent the Suzuki object. So for us to change the name property of the object created, we just need to set this.name equals to the name argument. And for the brand, even though we don't have a default value for it, we can still set it to the object instance in the constructor using the this keyword. And now, as you can see in the console log, the Suzuki object that we created out of this class has a customized name and brand, just like what we passed into the car constructor. Now the only item remaining for our class is the drive function. To define the function, we just need to type the name of the function and set it equal to an anonymous function. And in our drive function here, I'll just console out vroom vroom again. And that's it. I can now call the drive function on Suzuki. And we see vroom vroom in the console. That's a shorter way of defining a function in a class. We can put a round bracket right after the function name and skip the function keyword altogether. Defining a function this way is exactly identical to what we had previously. It's really just a personal preference. I like the short version better because I'm lazy. And that's it. Our class is completed. We can now create a new car easily using the class that we have just written, without writing everything from scratch. And again, just a quick demo, I'll create new instances of car and slightly change the name. These three objects are all different to each other and have their own name and brand. Can you see how easy it is to create a new object out of a class? And compared to what we had before, this way is much cleaner. Now the class syntax is actually only available after ES6. ES6 is a JavaScript version that was released back in 2015. It is one of the breakthroughs in JavaScript's history that has brought in a lot of good stuff. So prior to ES6, the way we create an object template is to use something called the constructor function. So here's how we declare it. I will replicate the car class using the constructor function. We'll start with a function keyword and give it a name. And again, we'll use the capital case. And this function will accept the name and the brand of the car. And inside the function, we can set the name and brand property using the this keyword. And the drive property will be an anonymous function. And that's it. And we can instantiate object out of this constructor function using the new keyword as well. There's one last thing I want to show you before we end the lesson. We can dynamically add a new function to our constructor function or class using the prototype. So let's say I want to add a start function to car. What I can do is to say car.prototype.start is equal to a function. Prototype is a special property that exists in every object. It is an advanced topic and I'll discuss it in a future video. For now, we just need to know that prototype can be used to add functions on a class. And now I can call the start function on the Suzuki object. And we see starting car in the console. If we do the same on our car1 constructor function, we'll get the same result as well. So I'll call the start function on new car, and we see starting from car1 in the console log as well. So that's a quick introduction to class and the constructor function in JavaScript. We'll learn more about object-oriented programming in the next lesson. Key takeaway for this lesson: class is the template for creating object. We use the new keyword to create object instances from class. A class constructor is a special function that runs whenever an object is instantiated. The constructor function is an alternative way to create an object template. The class and the constructor function have the same purpose. It is just a personal preference. That's it for this lesson, and I'll see you again shortly. Hey there, Sam. Imagine we're creating a game, and this game has different types of characters. Let's create a class for each of them. We'll have a knight class, and at the time when we instantiate this character, we should give it some health and magic in the constructor. And let's also add some methods to our knight. In object-oriented programming, a class function is also known as method. So the next time when you hear someone mentioning about the word method, they are simply referring to a function in an object or class. So a knight can walk, can fight, can ride, and can charge into an enemy. I will not implement these functions as they are not the purpose of this lesson. So I'll leave them empty as it is. Now, let's say I want to create a new character type called mage. And similar to a knight, a mage has health and magic as well. So the constructor will look pretty much the same. And the mage can walk and can fight as well. The mage probably couldn't ride or charge into an enemy. So I'll leave them out, and instead we're going to replace it with a function called cast, which will let the mage to cast a spell. Now, here's the issue. Both of our class looks very similar. We are repeating ourselves here, which is a big no-no. Is there a better way to do this? And the answer is obviously yes. We'll use something called inheritance to stop us from repeating ourselves. Inheritance is a concept of having a base class, or what we call a parent class, and we'll have daughter classes that would extend or inherit all the properties and methods from the base class. If that doesn't make sense to you, let's try to refactor our code so we can use inheritance to solve our issue here. So now let's create a base class, and I'll call it character. So the character class would contain common methods and properties that both our knight and mage class would have. So I'll move the constructor function to the character class and also the walk and fight method. And now our code is much more shorter than before. Let's make our knight and mage class inherit from the character class. To do that, we need to use the extend keyword. We'll just type out the extend keyword after the class name. So now knight is extending the character class and therefore has access to all the methods and properties from the character class. And we'll do the same for the mage class as well. And now let's create a new knight object and see if we can call the fight method. I'm going to add a console log inside the fight function definition and call the fight function on Karen. And it works. So Karen is a knight and is inheriting everything that characters has to offer. There's no limits on the inheritance level of a class. For example, if we want, we can create another class that extends knight. I'll call it warrior, and the extend keyword and knight. So now warrior is a grandchild of character. And again, it has access to all of the properties and functions of knight and character. There's one more thing I want to introduce to you, which is the super function. So let's say we might want to instantiate night differently than the other characters. In other words, we want to override the default constructor function, and to let night accept different arguments when we instantiate it. So to do that, we simply need to override the constructor function. Right? Well, yes and no. First of all, we're repeating ourselves to set the health and magic property. This is not good, and we shouldn't be doing this. Secondly, we see this error in the console, where JavaScript tells us to call the super function. So the super function is a special function that represents the constructor in the base class. And the super function is exactly what we want to avoid repeating ourselves here. We can replace these two lines with the super function to let the base class constructor set the health and magic properties for us. And that is pretty much it. The lines after the super function will be specific to the night class only, and we can customize however we want. So that's a quick intro to inheritance in object-oriented programming. It's a very powerful technique, but use it sparingly, because it has a massive drawback, as you'll see in the next few lessons. Key takeaway for this lesson: inheritance is a concept of a class extending another base class or parent class so that it can access all the properties and methods of the base class. The super function is a special function that represents the constructor of the base class, so that we can call the base constructor in the child class. That's it for now, and I'll see you again in the next video. Hey there, Sam! Polymorphism is a concept where there are classes that have the same methods, but different implementation. For example, suppose we are writing a payment gateway, where we will accept payment and also provide refund. Let's write a class for that. We will have a connect method, where this function will allow us to connect to our payment provider. And we should call this function inside the constructor, so we can connect to our payment provider at the time the object is created. We also need a pay method and a refund method to handle payment and refund. So that's our generic payment gateway. Now let's write some specific ones. We'll create a class called PayPal, and it will extend from payment gateway. Now PayPal should have its own pay, refund, and connect function. And those logic should be specific to PayPal, because PayPal will have its own rule when it comes to accepting payment and getting a refund. Next, we'll create another class called Visa, and similar to PayPal, it should extend payment gateway as well, and will have the pay, refund, and connect functions. And again, Visa will have its own rule, so the implementation of this function should be specific to Visa. Let's create one more example, MasterCard, and the same rules apply. It will have its own pay, refund, and connect functions. Now, can you see a pattern here? These classes have the exact same method, but their implementation is different. And that is exactly polymorphism. The same set of functions, but different classes and implementation. At this point, you might be asking, why is this useful? The answer is because we can reuse and write more generic code. Let's take a look at an example. Now, suppose we have a customer class, and the customer has a function that allows them to make a payment. When the customer wants to make a payment, they need to specify which gateway they want. In other words, they will need to choose whether to pay by card or PayPal. So we'll let the function to accept a gateway argument and the amount to pay. Since all the gateway has a pay function, we can simply call the pay method on the gateway object. And this is exactly the benefit of polymorphism. It is nice and neat, right? Without polymorphism, we might need to implement functions like pay by PayPal, pay by MasterCard, or pay by Visa, and implement the specific logic in each of these methods, which will make our customer class very messy and hard to maintain in the long run. So let's not do that. It's much more better to delegate those specific logic into their own class. And now moving on, our customer also needs the ability to get a refund. We'll create a getRefund method, which looks very similar to our makePayment method. Again, every gateway has a refund method, so we're just going to call it in here. And last but not least, the customer might complain if something went wrong. And now let's put everything together. Let's see how our classes will work with each other. First of all, I'm going to create a new customer called Karen, and we'll also create a PayPal object and a Visa object. And now when Karen wants to make a payment, we can just pass in the PayPal or card object into the makePayment method. And that's it. It's very clean and readable. But Karen will complain regardless. That's another benefit of using the polymorphism pattern. That is, in case we have a new provider in the future, we just need to create a new class for it without even touching the customer class. As long as our new payment gateway has the same methods as the others, we can be sure that our code will work. Alright, key takeaway for this lesson. Polymorphism is a concept where classes have the same method signature but different implementation. It helps us to write cleaner and more generic code, so our code will be easier to maintain in the long run. That's it for now, and I'll see you again in the next video. Hey there, Sam. Inheritance using the class syntax is great. However, it has a major flaw. That is, it's not very flexible. I'll show you what I mean. Let's say we have a class called animal. An animal can eat and sleep. And we have different types of animals out there. Let's create a mammal class, which extends from the animal class, and also a bird class, extends from the animal as well. Now, our first impression on birds is that they can fly. But that's not true. Ostrich and penguin are birds, but they can't fly. So it probably would make sense if we create two further subclasses for bird. Bird that can fly and bird that can't fly. In the bird can fly class, we'll add the fly method. Birds that can't fly either need to know how to run or swim. Ostrich can run but can't swim, while penguin can swim but can't run. So what should we do here? Should we create two new classes that says bird can't fly but can swim and bird can't fly but run? Can you see where this is going? It's getting more and more complicated. Inheritance using class, or what we call classical inheritance, is not very flexible. And things will get even worse when we take account into the bird's diet. Some birds are herbivorous and some are carnivorous. So we have vegan bird and meat lover bird. And that means we have to create even more classes to categorize the birds. So for the bird can fly and bird can't fly classes, we need to create two additional variants for each of them. The vegan variant and the meat lover variant. And things will get out of control very, very quickly. For the bird can't fly class, we need to create a vegan and meat lover variant as well. And for each of them, we need a swim and run variant again. The number of our classes will increase exponentially. And that will be a big nightmare for us to manage in the long run. And that's also another issue with classical inheritance. It's very hard for us to share functions with other classes. For example, imagine the fly method here is a very complicated function. Birds can fly, but there are other animals that can fly too. For example, insect or mammals like bat. It's either we copy and paste the code, which is very, very bad, or assigns the function using the prototype. Now, what if I tell you there's a solution that will solve everything that we just discussed? It is something called object composition rather than classical inheritance. So object composition is the idea of building an object using multiple smaller object blocks rather than defining a massive class where it is not flexible and hard to reuse. Let's take a look on how we can create an animal using the composition technique. First, we'll start with an animal object, and same as before, we'll have an it method inside the animal object. And now here's where we want to shift our mindset for a little bit. We need to think about what makes an animal rather than the animal category, because we're now going to build our animal using multiple building blocks. For example, I'll create a new building block called movable, and this movable object will contain all the logic to let an animal move. We'll also have another building block called flyable, which is for animals that can fly. And again, it will contain all the logic for an animal to fly. In regards to diet, we can create two additional blocks called can eat meat and can eat veggies for herbivores and carnivores. If an animal eats both meat and veggies, then we'll simply add these two blocks to the animal. We'll also add our swimmable block for animals that can swim and runnable block. And now our building blocks are ready. Let's see how we can create an animal using these building blocks. Let's create a penguin, and it is equal to a function. And the function will return a new object. So the idea here is that we're going to merge the building blocks that we have written so far with this object. There are two ways to do this. The first way is to use the spread operator. So we'll unpack the building block that we need into the penguin object. So the penguin is an animal, so we need the animal object, and also the movable, swimmable, and the can eat meat object. And that's it. Our penguin object is completed. So the next time we want to create a new penguin, we just need to simply call our penguin function. Let's see if that works. And we see the object in the console. So far, so good. The second way of merging objects together is to use the object assigned function, where we discussed in the previous video. So basically, the first argument is the target object, in other words, the object where we want to merge the other objects into. And the following arguments are the objects that we want to merge. So again, it'll be animal, movable, swimmable, and can eat meat. And our console log is printing out the same as before, so it's working just fine. I prefer the spread operator way, so I'll comment out object assigned. We also want the ability to let the user to customize the penguin object. So the penguin function should take in an argument, I'll call it option, and set the default value to an empty object. And back in the object, I'll just unpack the options. Now take a brief moment and review what we have done so far. Building an object using the compositional way is way cleaner and more flexible. We can reuse our building blocks on other objects as well. And we can easily add or take out features on different objects as we see fit. Isn't that neat? Let's create another example to make this concrete. I'll create an ego, and again, it'll take in an option argument. And to build the ego object, we need animal, movable, flyable, can eat meat, and the option argument. We don't even need to care about classes anymore. And that is the beauty of composition. It is highly flexible, and we can reuse the building blocks in any way we like. Comparing against classical inheritance, the composition way is much cleaner, right? Let's test our ego function. And it works. Now that we learned about the benefit of using composition over inheritance, does that mean we should ditch inheritance completely? The answer is no. There are still cases where inheritance can be very useful. In the end, it's just a personal preference and you should decide the structure of your program. However, as a general rule, I do prefer composition over inheritance, as I have less issues writing code in a composition way. Key takeaway for this lesson: inheritance is not very flexible and it can be hard to maintain, so use it sparingly. Object composition is a better way to create an object template rather than using a class. Object composition is the idea of building an object using smaller building blocks and join them together into one big object. That's it for now, and I'll see you again in the next video. Hey there, Sam. When you console log an object instance, have you ever seen a property called proto attached to the object instance? Confused? I'll show you what I mean. Let's say I have a constructor function called fruit that accepts an argument color, which I'll then use it to set to the color property of the object instance. Then I'll create a new object, banana, out of this constructor function. And let's console log out banana. So in the browser, as expected, we see our fruit object in the console. However, there's an extra property called proto in our object. What the hell is that? Let's expand it, and we see more crazy stuff. But hold on, this constructor property looks interesting. Does that look familiar to you? It looks like our fruit's constructor function here. Why don't we try it out? I'll create a new variable, apple, and set it to new banana proto constructor, and pass in our apple argument in it, and console log out apple, and it works. We're getting another instance of our fruit's constructor function. So what the hell is going on here? Let's go through it step by step. The proto property is a special object called prototype in JavaScript. JavaScript will automatically attach this proto property to every single object that we create in JavaScript. And everything in JavaScript is an object. By everything, I mean everything, except two things, null and undefined. So if I have a string here, since everything in JavaScript is an object, by theory, I should be able to grab the proto property of our string here. Let's console log it out. And there is something in there, and it is referring to the string's prototype object. Let's go through the rules of prototype in JavaScript. Rule number 1. Every constructor function or class has one and only one prototype object. So that means the prototype object is shared across all of the class or constructor's instances. Rule number 2. Every object instance has a proto property, as we've seen just now in our fruits instances. The proto property is a reference or link to the prototype object of their constructor function. Rule number 3. The prototype object has a property called constructor, which is referred to the constructor function itself, just like what we have seen just now when we created the apple object on line 17. Still confused? Let's put this on a diagram so we can visualize this. So here's our fruit constructor. And this is its one and only prototype. And we have instances on the left-hand side. So just now in our code, we created the banana object using the fruit's constructor function. And the banana's proto property is referring to our prototype here. And the prototype object has a constructor property that is pointing back to the constructor function itself. And we can use that constructor property to create new instances of fruits. One constructor function can only have one prototype. So if we have more instances of fruits, the proto property will point towards the same prototype object. Now spend a few moments and try to understand this diagram. If you can digest this, you will now understand the basic on how prototype works in JavaScript. So going back to our code, since the proto property is just a reference to the prototype object, so in theory, if we compare the two using the equal operator, we should get true. And we do get true, which means great, and I'm not lying to you. Now, object instances can access to all the functions that we put in inside the prototype object. So if we add an eat function to the prototype object, we can now call the eat function on all instances of fruit. Because again, based on rule number 1, the prototype object is shared across all of the instances. So now it brings us to another question. What's the difference between creating a function within a constructor function against storing the function inside a prototype object? If the question doesn't make sense, let's take a look at this example. Now suppose I have a constructor function called car, and I create a new instance method called drive using the this keyword. In other words, I'm creating this function inside the car constructor function. And now in the second case, I'll create another constructor function called car2, and this time I'll put a drive function inside the prototype. So what are the differences between these two? Which one is better? The answer is the car2 way is better and more efficient. Why? Because in the first way, every time we create a new car object, JavaScript has to create a new function from scratch and assign it to the drive instance property. So there will be one new function for each car instance. So if we got 1000 cars, that means JavaScript has to create 1000 drive functions for all these instances. In the second case, however, since we're storing the drive function inside the prototype, and the prototype is shared across all the instances, JavaScript no longer has to create the drive function from scratch for each new instance of car. So there's only one drive function. So that's why storing function inside the prototype object is better and more efficient. Before we move on, let's take a look at another example. We can create an array using a square bracket or using the array constructor function. We simply need to type in new array, just like how we create our fruits object. Now, based on what we have learned so far, would the proto property of our array instance equals to the prototype object? Pause the video and think about for a second. The answer is yes. Next question. Would the constructor property inside the prototype equals to the array constructor function itself? The answer is yes again. The last question. Would the constructor property inside the proto property equals to the array constructor function itself? The answer is yes, of course, because the proto property is referring to the prototype itself. If you got any of this wrong, be sure to re-watch this section and make sure you understand the basic of prototype, because we're going to dive even deeper next. Now I want to quickly show you something before we move on. Let's take a look on what is inside the array prototype. There are a lot of things in there. Do you find them familiar? These are the array functions that we have been using so far. So JavaScript stores all these functions inside the array prototype, instead of loading them in every single array instance. And just like what we have discussed before, this is a good thing to do because we're not wasting memory. Alright, let's move on. I want to introduce you something called the prototype chain in JavaScript. Everything in JavaScript is an object. So it's okay to say that everything in JavaScript inherits from the object constructor. And we know that every object has a proto property that refers to its prototype. And that brings us to a question. What is the prototype of a prototype? Let's see what will happen if I print out the proto property of the array's prototype. It seems like we're getting the prototype of the object constructor function. Let's test our theory. And we get true. What is going on here? So going back to the point that we made before, everything in JavaScript inherits from the object constructor. JavaScript actually builds its inheritance system based on the prototype. So when we try to access the proto property of the array's prototype, we're essentially accessing the prototype of array's parent, which is object. Let's go back to our diagram and go through this in more details. So we have the object constructor here as the parent of our fruit constructor function, and this is its prototype. So if we try to access the proto property on any of the fruits instance, it will point us to its parent's prototype, which in this case is the object's prototype. So let's put everything together. The object is the root ancestor of every data type in JavaScript. The other types of object, like array or our custom constructor function fruits here, simply inherits from the object. The inheritance system is based on prototype. So behind the scene, when we inherit something, JavaScript will simply build the new constructor function on top of the prototype of the parent object. So it kind of forms a chain of prototype, and we call this chain the prototype chain. And we can look up this chain by keep calling the proto property on any object instance, with each proto referring to its parent prototype. We're able to call the proto property until we reach the end of the chain, which is the object prototype. Now this brings us another question. What would happen if we print out the proto property of the object's prototype? We get now. Why? Because as we discussed, object is the root ancestor of everything, and there's nothing else above it, so its prototype will be now. Okay, let's take a look at a few more examples to make this concrete. I'll create a variable name and store a string in it. Our name variable here is now an instance of string. What do you think is the proto property of name? If we console log it, we see the string's prototype. And again, name is an instance of string, so the proto property would point at the string's constructor's prototype. What about the proto property of the string's prototype? We see the prototype of the object's constructor, because object is the parent of string, so we're simply getting the prototype of the parent here. And if we print out the proto property again on the object's prototype, we would see now, just like what we discussed before. Let's look at one more example before we move on. Let's create a num variable and set it to 1. What is the proto property of num? We'll console log it, and it is the prototype of the numbers constructor function. Next question, what is the proto property of the numbers prototype? Console log it, and we see the object's prototype as expected. Now let's move on. So we know that everything in the prototype object is accessible by all instances. Here's how it works behind the scene. When we try to call a function inside an object, JavaScript will first try to look for the function inside the object instance. If the function is not found, then JavaScript will try to look inside the prototype object of the constructor function. If it is still not found, then it will look inside the parent's prototype and keep going until we reach the root ancestor, which is the object constructor's prototype. So knowing that if we add a function to the object's prototype, that means this function will become available to all object instances in JavaScript. For example, if I add a function called hey to our object prototype, and I create a new instance of array, and try to call the hey function on fruits, guess what will happen? It works. Why? Because of the rules that we described just now. So when we call the hey function, JavaScript is going to look inside the fruits instance, which there's no function called hey. Next, it's going to move on to the array prototype, and there's still no such function called hey. So JavaScript will then move on to the next parent, which is the object instance, and find the hey function inside the prototype, which is the function that we just defined. So we see hey in our console. So the concept to take away from here is that every object instance has access to everything inside their ancestors' prototype objects. Now for the last part of this lesson, let's talk more about inheritance. Let's create a person class. If I console log out the prototype of person, we see it's a prototype as expected. And the proto property of the prototype is again pointing at the object prototype. Nothing special here, just like what we have seen so far. Now what about if I create a child class for the person class? Let's create a class called student and it extends from the person class. If we console log out the prototype of student, we still see the prototype of student, but now with a named person attached to it, because it is extending from the person class. So far so good. But what about the proto property of the student's prototype? We see the person's prototype. Why? Because person is the parent of student, and the proto property is pointing at a parent's prototype. So we see the person's prototype object. And if we go one more level up, we'll see the object's prototype again. And that's how JavaScript builds its inheritance system. Every time we create a child class, we're simply extending the prototype chain. The way JavaScript does things is very different than the other languages. The concept of the prototype object is very unique and different than the other programming languages. Again, the concept of prototype is an advanced topic in JavaScript. If you can understand this, you're now in a good position. Alright, key takeaway for this lesson. Prototype is a special object that is attached to every constructor function. A constructor function can only have one prototype, and it is shared across all its instances. So all the instances have access to the properties and functions inside the prototype object. The object constructor is the root ancestor of every data type in JavaScript. JavaScript's inheritance systems is based on the prototype chain. That's it for now, and I'll see you again in the next video. Hey there, Sam. Imagine we're writing a massive program. A program that has a few thousand lines long. Putting all this code inside one file is certainly not the best thing to do, because it is very messy and very hard to maintain in the long run. So what should we do then? Well, we could split our code up into multiple files and load them inside index.html in sequential order. that looks something like this. However, this is a no-go as well, because it's very hard to keep track of the variable names on the global scope. We could have the exact same variable declared in ep1.js and ep3.js. In other words, the global scope would be a mess to maintain if we were to write our program in this way. It's very hard to track what variables have been declared and what functions are available. So that's a no-go as well. Is there a solution for this? The answer is yes. It is called the ES6 modules. And just a quick recap, ES6 is the version of JavaScript that was released in 2015. And it brings in a lot of good features to JavaScript. And modules is just one of the many. The concept of module is where we write our code in small packages. All the variables and functions that we declared inside the module stay inside the module, unless we export them. And when we import this module in another file, the variables and functions that we exported will be usable. Let's take a look on how we can use modules in action. So I'm going to create a new file called app.js, and this is where we'll put our main logic in. And now, back in index.html, we will need to load app.js. Now, in order to make modules to work, we have to set the type attribute to module in our script tag. If we don't do that, JavaScript will throw us an error. Now, let's go back to app.js, and suppose we're building a calculator. We'll need some mathematical functions like add or subtract. Let's build a module for that. We're going to create a new file called math.js, and that will be our math module, where we store our mathematical functions. For modules, JavaScript actually allows us to use a .mjs extension rather than a normal .js extension. Using the .mjs extension makes it clear that this file is a module, but naming modules with a .js extension is okay as well. I'll use the .js extension for now. So inside our math.js module, let's define our mathematical functions. I'll quickly define two functions, add and subtract. For the add function, it'll take in an arbitrary numbers of arguments and calculate the sum. And the subtract function will look very similar to the add function. Once we're finished defining the functions, it's time for us to export these two functions. Here are the rules when it comes to exporting modules. Rule number 1, we can export multiple things in one file. As you'll see later, we'll be exporting the add function and our subtract function here. Rule number 2, there are two types of export. One is called export default, which is also known as a name export. The other one is called name export. Let's explore them in more details. With export default, whatever we exported in this way will become the default import of this module. Here's the syntax. We simply need to type in the export keyword and the default keyword. And whatever we put after the default keyword will become whatever we import. So if I put a string ABC here, it will become the default import of this module. Let's try to import this module in our app.js file. So to import our default export, we need to type the import keyword and give a name to our unnamed export. In this case, I'll just call it math. And after that, we have to specify which module we're importing. So we'll use the from keyword and the path to our module. Now, if we console out math, we should see the string ABC, because ABC is the default export of our math module. Let's run this in our browser, and we see the string ABC in the console. So far, so good. An important takeaway here is that whatever we export will be whatever we import. And typically, we will put an object in the default export. Let's try to export our subtract function. And we can already see the console log in our app.js is printing out an object that contains one property, which is our subtract function. So back in app.js, if we want to use our subtract function, we just need to call the subtract property from the math object. And it works. Alright, next, let's talk about name export. So name export is pretty similar to default export. The difference is we don't put in the default keyword when we're exporting, and when we're importing, we have to be specific on what we're importing from the module. So let's try to export our add function using the name export method. So we're just going to type in the export keyword and followed by the object and put our add function in it. Now back in app.js, to import a name export, again, we're going to use the import keyword. And now we have to specify which item we want to import from the module. The way to do that is to use a pair of curly braces and put in the name that we want to import. We're importing the add function here. So I'm just going to type in add, and after that, similar as before, we'll use a from keyword and the path of our module. And now let's try our add function. And it works. Sometimes we want to override the name of the export. So to override our add import here, we could use the as keyword and supply our own custom name after it. And now in the console log, instead of calling the add function, we'll just call our some other name variable. And it works just like before. The reason why we might want to override the default name of our import is that we could have variable named collisions in the same file. So using the as keyword, we could name our import differently and avoid any collision if there's any. There's no restriction on how many export we can use inside one module. We can have as many as we like. So I could export a variable hey here, and another function called hello, and back in app.js, we can import them separately inside the curly braces. However, it's a good practice that we put everything inside an object under one export keyword, because it's clearer and we don't need to look for the export keywords all over the place. Alright, key takeaway for this lesson. ES6 modules help us to organize our code and improve reusability across our app. We can just write our module once and import it anywhere in our app. There are two types of export, the default export and the name export. When we import a name export, we'll need to specify what item to import, but not with default export. That's it for now, and I'll see you again in the next video. If you enjoyed the content of this video, don't forget to hit the like, subscribe, and the bell icon for more content to come. It will really help me out. Thanks for the support.